In the previous session, we have discussed about register organization. So, as we have seen in the previous session, there are some registers that are being present in the internal architecture of 8086. So, what is the purpose of registers? The purpose of registers is to store the data. Okay, so we have some 4 different types of registers available in the 8086 microprocessor architecture. The first one is general purpose registers. Second one is pointer and index registers. Third one is flag registers, and the fourth one is segment registers. Okay, so in the previous session we have discussed about the first 3 categories in the registers what you have in the architecture of 8086. Today in this session we will be going to see a very important part through which you can able to understand the working of 8086 microprocessor very easily. If the segment registers if you are unable to understand, then you can't be able to know what the workflow is and how the instructions are being processed. Right. So for that we need to know the memory segmentation. So what is this memory segmentation? Nothing but whatever the physical memory we have. Suppose this is my physical memory, which we can call as one box. Right? So one box here, this is my memory. So it has to be segmented into some segments. Nothing but it has to be divided into some blocks, into some segments I can call. Okay, that segments can be each segment is divided into 64 kilobytes of space. 64 kilobytes of space, 64,000 bytes. For each segment it is being divided into 64 kilobytes. On a whole, the memory space is 1 megabyte. As we all know, 8086 is a 20-bit address bus through which 2 power 20 nothing but 1 megabyte of space we can able to access in for your 8086 microprocessor. So each segment is being divided into the physical memory is being divided into 4 segments, which we call as the first segment, which is code segment. Second is data segment. Third one is extra segment, and the fourth one is stack segment. So as it is 1 megabyte of memory space, its address starts from 5 zeros H in hexadecimal value to 5Fs H. So this is the starting address of the memory and this is the final address of the memory. So this 1 megabyte of memory is being segmented into 4 segments. First one code, second one data, third one extra, fourth one stack. Okay, so this complete memory is divided into 4 segments. They are not physically being divided. We can call as a virtually divided, nothing but logically divided segments. So first thing is code segment. So what this code segment consists of in the memory? Code is nothing but program, right? Code is nothing but program. So in this segment, the program will be stored. The instructions will be stored. Nothing but as we are dealing with as we are dealing with assembly language. So in this assembly language program, code segment will be storing the instructions that need to be executed. Clear? Next, data segment. In the data segment, it will store the data required to process. Getting a point? In the code segment, we will be storing the code, instructions. Data segment, it will store the data. Extra segment can also store the data, will also be able to store the data. The data which the extra segment can store is the extra data where the data segment is unable to store. That data can be able to store in your extra segment. Getting a point here? These both are same, but the thing is, here the data will be stored up to 64 kilobytes. If we have more amount of data, we can use the extra segment also. Getting a point here? So data segment followed by extra segment. Both are useful for storing the data. Now coming to the fourth and final segment, which is stack segment. Stack segment means stack. It follows the stack, nothing but last in, first out. So we have some memory space in that one. Whatever the last instruction being stored, that will be executed first. Top of the stack, which instruction is present, that will be executed first in this stack segment. So that part will be stored in your stack segment. Getting your point? Right. So here we have 4 segments, right? So they are being divided 64 kilobytes each. Nothing but 4 zeros to 4 Fs like that. 1 4 zeros by 1 4 Fs, then 2 4 zeros by like that. So it will divide the number of addresses like that. Okay. Size of a segment is 64 kilobytes. A segment may be located anywhere in the memory. Each of the segment can be used for a specific function. So as I told you, code segment is used for storing the instructions. The stack segment is used as a stack and is used to store the return addresses. The data and extra segments are used for data byte, as I told to you. So the segments can be overlapped or non-overlapped. Can be overlapped or non-overlapped. Non-overlapped means simple. The segments which does not overlap with each other are called as non-overlapped segments. Okay, nothing but, for example, if my code segment address is 4 zeros to 4 Fs and my data segment is 1 4 zeros to 1 4 Fs, means they are not overlapping with each other. And some segments can be overlapped, but some part of address some part of data can be in your data segment, as well as some part of data can be stored in your extra segment. So that how the overlapped segments may be. Right? Now here we need to see, as in our architecture we have seen, the summation block calculates the physical address of the memory. right? So for calculating that physical address, we require two addresses. What thing we require? The starting address of the segment, this or this or this, whatever segment we are using, we want the starting address, nothing but, for example, as I told you before, if we are present in our college at 405 room, so the starting address is 400 or fourth floor, third floor, right? And offset address is your fifth room. Getting a point here. So if the starting address is my physical address and the location exactly where you are in the code segment is my offset address. So physical address you can calculate by this thing. So actual physical address, it will be a 20-bit address, right? But the starting address and the offset address are my 16 bits. Getting a point? So whatever the segment address is, whatever the segment address is into 10 in hexadecimal, 10 in hexadecimal is 16, right? Plus offset address gives my physical address of 20 bits. Getting a point here? Once again, how to calculate the physical address? So whatever the segment address, nothing but it might be a core segment, or it might be a data segment, or it might be a extra segment, or it might be a stack segment. That starting address into 10 in hexadecimal plus the offset value. Offset value is into the segment which place or which address the data is. Segment address, the starting address of the particular segment. If you add, we'll get as the physical address which is of 20 bit. And this physical address is the address of the data in the memory being stored. Getting a point? Clear? See here. Segment address into 10H plus offset value. If you add, you get a 20-bit physical address. We'll see one example. Following example shows the code segment IP scheme of address formation. So instruction pointer is a offset address for your code segment. Getting a point here? For code segment, what is my offset? Is instruction pointer. Instruction pointer address. Suppose CS is 34BA and IP is 8JB4. Right. So 34BA is my segment address and 8JB4 is my offset address. So what should I need to do? I need to take the segment register which is 34BA, right, into 10 nothing but 0 plus what is my offset address? 8JB4. If I add, let us 3D654 is my next address where I need to fetch the instructions from it. Getting a point here? Clear? So 3D654 is my physical address. So it will go to that corresponding physical address. The data will be fetched to the instruction queue and continue the process. Okay. Now coming to the respective segment address and its respective offset address. For code segment, we have register which will store the offset address of the data stored, or I can call the offset address of the instructions stored in the code segment. Getting a point? Coming to the stack segment, we have two: stack pointer, base pointer. Stack pointer, top of the stack; base pointer, remaining of the stack. DS, SI, source index. DS can be destination also. Extra segment for string operations, it uses DI. This is about the memory segmentation. Thank you.